Here we go, Spartan fans. 7.3 trig equations. Okay, let's do a really quick review of some very basic algebra 1 stuff. If you have quantity 2x plus 1 times the quantity x minus 3 equals 0, probably can solve this off the top of your head, which I actually hope you can, but we're going to use the zero product property in case you have forgotten the names. And you would set each factor equal to 0. Again, you do not have to show this step, but I'm reviewing it for a reason. And you would say x equals -1/2 and x equals 3. And technically, you don't have to, but we really should be using those brackets. Okay, great. That's going to come into play in a little bit. Let's also go back, and you probably don't remember this, and that's okay. That's why we're going to review it. The Pythagorean trig identity. You don't have to know the names, but it's super important that you do. Okay, I just got done saying you don't have to, and then I said it's important. It's helpful. Pythagorean trig identity. Okay. Pythagorean theorem, a squared plus b squared equals c squared. So I am going to do a very quick review of it. You may not remember, that's okay. You have some angle theta. Here's your x, here's your y, but on the unit circle, x represents the cosine, y represents the sine, and of course the hypotenuse is 1. Pythagorean theorem, cosine squared plus sine squared equals 1. I, of course, prefer to write it as theta. Notation, this is sine times sine, which is sine squared. We don't put it in parentheses and then square it. This is just easier notation. This is critical. I would highlight it in my notes. You need to make sure you know that sine squared plus cosine squared is 1. It is the most important identity in all of trigonometry. Okay, so we're going to put the two things together and we're going to solve. So we've got this identity involving sines and cosines, and we've got the zero product property. So let's do a couple examples that sort of ties all these things into play. So if I give you something such as, how about the sine theta, how about this, 2 sine theta minus 1 times the quantity, how about tangent theta plus 2 equals 0. Okay, so zero product property. So we would say 2 times the sine of theta minus 1 equals 0. Feel free to skip that step. Tangent theta plus 2 equals 0. Again, feel free to skip this step. So now we're going to be working backwards, and I'm going to say the sine of theta is 1/2. I'm not using inverse notation. So, and let's solve from 0 to 2 pi. Otherwise, right, the sine curve is cyclical and you could be solving, forever. So we're going to just look at from 0 to 2 pi, and the interval will be given to you. Make sure you read the directions. So where is the sine theta 1/2? Well, from 0 to 2 pi, and by the way, radians, not degrees. So if this were a quiz or a test and the direction said 0 to 2 pi and you gave me degrees, you would lose points. Well, how do you know you're in radians? Well, if it said 360 degrees, you'd be in degrees. So where is the sine 1/2? And the last I checked, that would be at pi over 6 and 5 pi over 6. Knowing the unit circle is critical. And then here we would say the tangent of theta is -2. Okay, so the tangent of theta is -2 somewhere. I don't know off the top of my head. We would use a calculator to solve this, which we will do later. you are not expected to know where the tangent is -2 without your calculator. And then, of course, whatever you got here, okay? Okay. So let's look at this whole sine squared plus cosine squared, and how does that fit into the zero product property? Okay. So let's say you have cosine squared theta minus sine squared theta. Ooh, that's close. It's close, but no cigar, as they say. Okay. Well, there's too many variables. Like it's a quadratic, right? It's got a squared. And the goal is to be able to do some kind of factoring maybe. So here, the zero product property, the factors were given to you, but maybe if I could factor this, I could solve, but it looks too many, there's too many variables, or too many functions, I should say. We've got a cosine function and a sine function, and those are both squared. And then I have this singular, to the first power singular, I have this singular sine function. So I can do a substitution. I can manipulate sine squared plus cosine squared equals 1. I can manipulate that. And this is going to become, I keep saying this a lot, and I know I repeat myself that it's important, but it is. I could isolate sine squared, and I could say, let me just write it off to the side here. I could say that sine squared is the same as 1 minus cosine squared. These are the same. I could also say that cosine squared is 1 minus sine squared. I can manipulate by doing some addition and subtraction. Well, this looks a little bit better to me now because I can do a substitution. So how do you know which one to substitute? How do I know, should I take out cosine squared and put in 1 minus sine squared? Or should I take out sine squared and put in 1 minus cosine squared? Well, let's just try. And I'm going to do it the wrong way first, just so you know. My pencil here. Let's say you decided to take out the sine squared. Okay, so if you take out the sine squared, and I am going to erase this. Sine squared is 1 minus cosine squared. Well, this is going to give you 2 cosine squared when you distribute. This is going to give you 2 cosine squared. And then you have a sine, and that doesn't help me. What I need to do is get the the equation written with one function. Okay. So if I take out the cosine squared instead, and I write it as 1 minus sine squared, so I'm going to take out the cosine squared, and I'm going to write it as 1 minus sine squared, then minus sine squared plus sine theta equals 0. And now I can combine like terms, and I have all sines, and I can try and do some factoring. So let's combine like terms. Negative sine squared is negative 2 sine squared. I'm writing it in standard form. Plus sine plus 1 equals 0. I really dislike factoring with the lead coefficient being negative. Feel free, I'm always going to change it. So I'm going to divide everything by -1. Okay, this is factorable. You can factor with trig functions. You can factor with trig functions. So let's do it off to the side if you are a little bit confused about what's going to happen. Let's just say we wrote it as 2x squared minus x minus 1. Okay, well, you would just factor this, right? This is 2x 1. How about negative, positive? You would factor it and you would get 2x plus 1, x minus 1. I really hope I did that right. I hope that's right. Yeah. Okay, well, instead of using, x, I'm going to use sine. So this is going to factor as 2 sine theta plus 1 times sine theta minus 1. And now use the zero product property. 2 sine theta plus 1 is 0. So the sine of theta is negative 1/2. Or the sine of theta is 1. Okay, so sine is negative 1/2. I believe that is at 7 pi over 6. 11 pi over 6. And the sine of theta is 1 at pi over 2. 3 answers. I wish that there was some shortcut and I could say to you, oh, if the problem looks like such, there'll be 2 answers. If the problem looks like such, there'll be 4 answers. There's really no way of, unless you know and I don't, there's no way of knowing ahead of time. Like here, this was going to be 3 answers. Here, this is going to be 3 answers. Okay. All right, let's take a look at, of course, a few problems that are a little bit different. Let's look at 4 cosine squared theta minus 3 equals 0. We don't need to do any substituting. So in the previous problem, we took out cosine squared and we put in 1 minus sine squared. We only have one function here, so we're good to go. So this looks kind of, this isn't so hard, but let's take a look. So I'm just going to solve for cosine squared. Again, you can skip these steps. So 4 cosine squared equals 3. Cosine squared equals 3/4. And then you square root both sides. And here's what's going to happen for some of you. When you square root, plus or minus. And if you forget the plus or minus, in this particular case, you're going to be not just eliminating one answer, but eliminating 2 answers. So this is going to be the cosine of theta is plus or minus root 3 over 2. Now notice I'm not using an inverse. I'm not using inverse notation. This is like a basic straight out solving. So I don't need to worry about the range. I don't need to worry about the range. So I could have multiple answers. So the cosine, well, I want all the positive values. Oh, again, sorry. 0 to 2 pi. I want the positive cosines and the negative cosines. That's all 4 quadrants. That's all 4 quadrants. So the reference angle, I believe, is going to be 30 degrees again, pi over 6. So first quadrant, pi over 6. Second quadrant, 5 pi over 6. Third quadrant, 7 pi over 6. Fourth quadrant, 11 pi over 6. So this particular problem has 4 answers. Let's look at tangent. And tangent, at least for me, I don't like the tangents because I don't know them as fast as I know the other ones. But tangent to theta is -1. The tangent of 2 theta is -1. Okay, so I'm going to do a substitution. And I'm going to say, let x equal 2 theta. So the tangent x is -1. Okay, and so that is going to be, tangent is negative in quadrants 2 and 4 with a 45-degree reference. So in quadrant 2, 45 degrees is going to be 3 pi over 4. And in quadrant 4, 7 pi over 4. Great. So I said this is what x is, but now I want x to equal 2 theta. So now I'm going to do a reverse substitution. So this is what x is, but that needs to equal to 2 theta. So 2 theta is 3 pi over 4. And 2 theta is 7 pi over 4. I did a substitution and I said, okay, 2 theta is x. So I said, okay, here's taking out the 2 theta, I'm putting in x, and I solved for x. Now I'm going back and saying x is the same as 2 theta, solve. Well, here we go. Theta is 3 pi over 8. And how about 7 pi over 8? And you think you're done, but you're not. Tangent is special. Okay, so if I'm solving from 0 to 2 pi, if I'm solving from 0 to 2 pi, there are actually more answers. And that is because the period of tangent is pi. So let's just do a really quick sketch of that. The period of tangent is pi. I'm going to draw a negative pi over 2. Nope, I have that wrong. I have it right. I was doubting myself. This is right. Okay, so here's the graph of tangent. That's the parent from negative pi over 2 to positive pi over 2. But I want to solve this from 0 to 2 pi. Pi over 2 pi. This is pi. Up to 2 pi. Okay. So I want the tangent to be -1. Okay, whatever. Tangent is -1 down here somewhere. Okay, so if I'm going across from 0 to 2 pi, my line crosses the graph in 2 places, which is how I got 3 pi over 4 and 7 pi over 4. But now I'm multiplying that angle times 2. So if the period of tangent is pi, the period of tangent is pi, I need to add pi to my answers. So 3 pi over 8 plus my period of pi, so that's the same thing as 8 pi over 8. I'm now also going to have an answer of 11 pi over 8. I'll show you why this works. 7 pi over 8 plus pi is 15 pi over 8. You could keep adding pi. Here's the issue though. If I add another pi, that would be 19 pi over 8. but 19 pi over 8 is greater than 2 pi, and I'm only solving from 0 to 2 pi. And actually, I can't think of a time when you're not going to solve from 0 to 2 pi. I don't think it's ever 0 to 3 pi or whatever. So here's what happened. Let's check our work. Let's check our work. Let's say, so let's just do a quick check here. Let's say theta is, let's just check 11 pi over 8. So the tangent of 2 theta, and I'm saying theta is 11 pi over 8. Does that equal -1? Okay, well, 2 times 11 pi over 8 is 11 pi over 4. Is the tangent of 11 pi over 4 -1? Sure is. 11 pi over 4 is in quadrant 2, and the tangent, and it's 45-degree reference. So this ends up being quadrant 2, 45 degrees, and it is indeed -1. So in this particular problem, there are 4 answers. The only time you really need to worry about having to, like I added pi because the period is pi, the only time you really need to worry about that is for tangent and cotangent. And that is because sine, cosine, cosecant, secant have a period of 2 pi. And so for the most part, you're going to be okay with that. What happens? Now I just got done telling you that rarely are you not going to solve from 0 to 2 pi. However, what happens if they just ask you to solve outright and there's no restriction? So you're asked to just solve it outright and there's no restriction. Let's look at, how about, let's just stick with sine. It's a little bit easier. For me at least, sorry. So let's just solve. I want to know all the possible solutions. I want to know all the possible solutions. So generally you'll see this written as, the directions will say, give a general formula. So I'm going to say, you do not have to do the let x equals 2 theta. I think some of you can probably do that off the top of your head, whatever. I'm going to show it the other way. So if x is 2 theta, then I want to solve for the sine of x equals -1. Okay, and the sine is -1 at 3 pi over 2. Okay, so if x is 3 pi over 2, then 3 pi over 2 equals 2 theta. Theta is 3 pi over 4. I think, yeah. So how am I going to write a general formula for this? And you'll also be asked, like, give the first 3 or 4 solutions or whatever. So again, let's go back to the graph. So omega, coefficient on the variable. So in this case, it's 2. So here the period is pi. Okay, so let's just do a really quick graph. And actually, I'm going to draw a bit nicer than I usually do. So if the period is pi, period is pi. Boom, boom, boom. Boom, boom. Great. So it's 3 pi over 4. When am I going to hit a sign of -1 again? When am I going to hit a sign of -1 again? Okay, well, let's just keep going. I mean, you don't really have to, but 5 pi over 4, 3 pi over 2, 7 pi over 4. That's not right. 7 pi over 4. How long does it take before I hit -1 again? All right, well, here the sign is -1. Here the sign is -1. That's a distance of pi because that's the period. So where would the next time that I hit -1? Well, that would be, I think, 11 pi over 4, I believe. So if I were to go down here and I were to keep graphing it, the next x interval, the next theta would be 11 pi over 4. So initially, just one answer is 3 pi over 4, but another pi, why is it pi? Because the period is pi. So another pi would be 7 pi over 4, 11 pi over 4. How can I write that as a generic formula? So 3, 7, 11, let's say 3 pi over 4 plus pi times some constant k. I don't know why we use k for a constant. I think you guys use that in chemistry maybe. In the next video, we will look at solving trig equations on the calculator.